Hey Chemistry, Mrs. KJ here, going over 3.10, metalloids. Metalloids are located between the metals and nonmetals on the periodic table. In this lesson, you will learn about the group of elements called metalloids. Metalloids sometimes exhibit the properties of metals and sometimes exhibit properties of certain nonmetals. So they are the in-between, which makes sense because they are located in between the metals and the nonmetals. And the word part oid means like or kinda. So they are kinda like the metals, but they're kinda like the nonmetals. So periodic table groups some elements as metalloids. They are located between the metals and nonmetals, and it's often called a stair step because if you look, it kind of looks like a set of steps. So they call it the stair step between the metals and the nonmetals. Properties: they may be shiny or they may be dull. They're somewhat malleable. They're somewhat ductile. They conduct heat and electricity somewhat. So again, they're in between. So you can download your study guide. The metalloids are a group of elements that share some properties of metals and some properties of certain nonmetals. You have now explored the majority of the periodic table, but there is one group that you have yet to examine, which is situated between the metals and the nonmetals on the periodic table. These metals are the metalloids. These elements are sometimes referred to as semi-metals. Because what does semi mean? Think of a semicircle. Semi means half. So it's kind of like it's half metal, half nonmetal. By either name, these elements occur in a stair-shaped arrangement on the periodic table, which they show here in purple. The metalloids are the elements boron, silicon, germanium, arsenic, antimony, tellurium, and acetine. Metalloids may have certain properties similar to those of metals or those of certain nonmetals. Metalloids do not have their own set of distinguishing properties. Under some conditions, a specific metalloid may show properties similar to those of a metal. Under different conditions, like maybe a much colder temperature, it may be more similar to one of the nonmetals. Or there is a chance that it will exhibit properties that are neither like those of metals or those of nonmetals. Silicon, Si, is a metalloid that is used in computer chips and other high-tech applications. And that's why they call it Silicon Valley in California, because that's where they do a lot of that stuff. By itself, elemental silicon is a poor conductor of electricity. In this way, silicon is like a nonmetal, as nonmetals are poor conductors. However, if silicon is combined with boron, another metalloid, the silicon-boron mixture will conduct electricity very well. Silicon is the most prominent material used in the semiconductor industry. Note that the industry itself is named for the property of silicon and other metalloids. So that's where it is on the periodic table. Properties of metalloids tend to fall in between the properties of metals and nonmetals. Recall that metals are good conductors of heat and electricity, and most nonmetals are typically poor conductors of heat and electricity. Metalloids fall somewhere in between. They are better conductors than nonmetals, but worse conductors than metals. Like metals, most metalloids are solids, but these solids tend to be brittle and not very shiny, which is more similar to the properties of nonmetals. On the whole, metalloids are also malleable and ductile, although generally not quite as malleable and ductile as metals. So not only are metalloids in between metals and nonmetals on the periodic table, they are also in the middle in terms of their property. So, luster. Metals are the shiniest, metalloids shiny to dull, nonmetals are dull, if they're solid at all. Conductivity. High for metals, moderate for metalloids, little or none for nonmetals. Heat of conduction. High for metals, moderate for metalloids, little or none for nonmetals. So you see the same thing for ductility and malleability. High for metals, medium for metalloids, little or none for nonmetals. So this comes into play where if they give you three elements and they say, which one is the shiniest? Which one is the least shiniest? Then you can say, oh, well, the metal is the most shiny. Whichever one's the metalloid goes in the middle, and the nonmetal goes at the end for being the least shiny. Metalloids are some of the most useful of all elements because of their moderate properties. So because they're in between, we can actually use them for a lot of stuff. Arsenic is a metalloid that is poisonous, amongst other things. Arsenic, As, is element 33 on the periodic table. So if we want to see, that's where it's located. Compounds of arsenic are deadly to humans and have been used as poisons since ancient times. And it's in a lot of books, too. So you've probably heard of arsenic. Arsenic disrupts the cellular respiration systems of cells so that no ATP is produced. And what does the cell use ATP for? It uses it for energy. So basically, it shuts down your cells. Arsenic has many positive applications too. It is found in insecticides and pesticides, in bronzing applications, and in pyrotechnics such as fireworks. Again, it's combined with something so that when the fireworks rain down, it doesn't kill everyone below it. Most wood that is treated chemically to resist rotting is treated with arsenic compounds that are forced into the wood by high pressure. Rarely is arsenic or any other metalloid found without being combined with other elements. This is a rare photo of nearly pure arsenic. Antimony. Antimony is a metalloid that may look like a metal but does not share the properties of metals. Antimony has an atomic number 51 and is a metalloid. It is used in many applications including paints, batteries, matches, and some medicines. Antimony can be found in more than 100 different minerals in Earth's crust. It is most often found in the minerals stibnite, Sb2S3, and velatinite, Sb2O3. Antimony may look like a metal. It is shiny and gray, but it does not conduct electricity or heat well. This common-looking mineral is antimony. Even ancient Egyptians found uses for the element. They used it in the form of stibnite as eye makeup. Germanium was one of the blank spots on Mendeleev's periodic table. Dmitry Mendeleev predicted the properties of germanium, but this element was not discovered until after he published his periodic table. Germanium, named after Germany, was discovered in 1886. It is found in deposits of germanite, Cu13, so 13 copper atoms, 2 iron atoms, 2 germanium atoms, and 16 sulfur atoms, which is mostly in Namibia. Germanium has an atomic number of 32 and is a metalloid with properties similar to the metal tin, Sn. Germanium is a solid, but it's brittle under normal conditions. Germanium is a good semiconductor as well. A semiconductor can conduct electricity under some conditions, but not all. Germanium has many applications in electronics, fiber optics, and transitions. So you might have noticed the metalloids are used a lot in modern technology. Germanium was used in transistors and diodes, which are ancestors of today's more sleek electronic components. Silicon is an important metalloid. Silicon, Si, is the second most abundant element in the Earth's crust. It has an atomic number of 14 and is an important metalloid used in computer technology. Silicon is a better semiconductor than other metalloids, such as germanium, because it retains its properties as a semiconductor at higher temperatures. So you know how they worry about computers overheating? This is part of why, because it has to do with the heat that the elements can handle and still perform the way that they should to make your computer work perfectly. Other metalloids lose their ability to conduct electricity as temperature increases. Silicon has a variety of uses, including integrated circuitry, computer chips, and transistors, but it is also found in glass, ceramics, and concrete. Because it is so abundant in the Earth's crust, silicon is readily available. It is found in minerals such as feldspar, quartz, and micas. Silicon chips are found in almost every electronic device made today. Pure silicon is rarely found and looks like most other minerals. Usually silicon is found combined with other elements. Sand is a combination of silicon and oxygen. Considering silicon's wide availability, a shortage of this element is unlikely to occur in the near future. Boron is an important nutrient for plants. Boron, B, the metalloid with the atomic number 5, is similar in many ways to the nonmetal carbon. Both of these elements are black in color and are poor conductors of electricity. Boron has been used for thousands of years. In ancient Egypt, the mummification process used a compound that contained boron. Boron does not exist on its own in nature, but is found in substances such as borax or boric acid. Borax is often an ingredient in detergents. Ooh, and if you have some borax at home, send me a K-mail. I'll let you know a nice little fun way that you can make slime or gack out of borax. Boron is used to give some fireworks their green color. Boron is a nutrient for plants and is also used in jet fuels and in the building of rockets because of its light weight. Among other uses, boron gives a green color to fireworks. The metalloids are a diverse group of elements. The metalloids are a small but diverse group of elements on the periodic table. They are found at the boundary between the metals and the nonmetals and also share properties with both. Remember, they're kind of the in-betweens. Metalloids have a wide range of applications, including use in semiconductors and poisons, as well as fireworks. Periodic table. Some groups in the elements are metalloids. Properties may be shiny or dull, somewhat malleable, somewhat ductile, conduct heat and electricity, somewhat. And it's located in the stairs between the metals and the nonmetals. Again, we like to call this the stair step of the metalloids that separates them. All right, let's go ahead and let's add to our notes. All right, so if we look at our notes, I kept the first paragraph in the goals, keywords and pronunciations, metalloid, an element that exhibits both metallic and nonmetallic properties. It's not as strong in the properties, like being shiny, ductile, malleable, and conductive as metals, but it is stronger than the nonmetals. So remember, it's the in-between. Semiconductor, a material that can conduct electricity under some conditions, but not all. And metalloids are also called semi-metals, because remember, they're kind of like weak metals. And metalloids are vital for modern technologies such as computers. And that's it for this one. Good luck on your quiz.